So today on the rack we have a 1987 911 Carrera. This is a car that we've had in our shop and we did AC on it last year. Although we do have a complaint where the AC is not blowing cold, so we're going to look at that in a little bit. But one of the biggest issues that this particular customer was complaining about was oil leaks. So underneath the car is actually pretty clean. We've got a little bit of seepage. This looks like it's coming possibly from rocker shaft area. We need to go in and do rocker shaft torques. This could be blowing back. Possibly camshaft O-ring, very, very minor leak-wise. A little bit of oil on the cam box, which doesn't really concern me too much. Engine as a whole is pretty dry. I mean, this is all the factory wax on it, and you want to leave this on. I see a lot of people cleaning this stuff off, which is not a good idea. This will actually preserve the engine. We've got a little bit of weepage coming from the lower oil cooler area, and I believe this is coming from right here. There's a TSB on this issue with putting sealant to seal that little steel insert in there for that oil passageway. Then if we look out a little bit further, we've got some cam box leakage here. Although I would probably hazard a guess that's more from rocker shafts than actual cam box leakage. Somebody's already done oil return tubes and they seem fine. The S-hose right here, it's rock hard. It's also showing a crack right here, so it's definitely due to be replaced. Transmission wise, same thing, is all in good shape. No obvious signs of leakage. It is time for a major service. He has 25,000 miles on the clock. This is a very low mileage, very clean car, but has the factory wax protection on it, but also no signs of leakage. All right, so in looking under the car, I notice right here we have a fresh impact up and over here, down the rest of the floor pan, and straight into our AC line. I can see here there's an obvious penetration. So it looks like there's the cause of our leak. I will pull a vacuum on it and just see what it does, but looking at the oil around the line, it's pretty straightforward. Also looks like the rear sway bar link took a sizable hit as well, and it's in that same plane of whatever this thing hit right there. So looking in the top, nothing up here looks horrible. I mean, obviously I have to delve in a little bit deeper, get the covers off to take a look, see what's going in, but nothing is really screaming any major issues. Everything looks to be in pretty good shape. Fuel lines on these actually look to be in pretty good shape. They still move, not rock hard. This is something as cars get older you got to look at. But on whole, it's a pretty clean looking car. So performing major services is important because it allows us to not only maintain the vehicle, but also kind of monitor what things are coming up, what things need to be done, as well as maintaining a good running sound vehicle. So this is a really low mileage car. It hasn't had a lot of service. One of the big things about a 30K service is all of the fluids are changed. This means transmission oils and engine oils, brake fluids. It gives us a chance to kind of see in how these things are wearing and give us any warning points that we need to keep an eye on. So I have the transmission drain plug, and first look, it always looks pretty scary. What I'm just going to do is squish this. And what I'm looking for is big chunks of something. All of this powdery stuff here is what I would say normal wear and tear. Now this particular car, somebody has been in the transmission once before. The actual service schedule says on the later model vehicles you can go 60,000 miles on transmission oil. I always stick with the 30,000 mile mark. I would much rather know sooner than later what's going on in there, and if there's something that we can avoid a major repair, then I'd rather get it at 30 than wait till 60 when we're pulling a transmission out for issues. But other than it looks ugly, pretty soft and squishy. I mean, it's all metal wearing from synchros and selectors, but there's no big chunks in it. No chips of gear teeth or dog teeth or anything in there. So we're just going to clean it off, put it back in, and refill the transmission. Okay, very important not to over tighten these. When I pulled these out, the last person in there, it was so tight I had to put a 10mm Allen key in there and a 2-foot bar to crack these things loose because I just couldn't break them free. So make sure you torque them to 45 Newton meters, and it takes the same aluminum crush seal as the engine oil drain plug. Torque, once again, is 45 Newton meters. Very important fact when draining transmissions, always make sure you get the fill plug out first. This one you can see the last guy, they damaged the plug a little because they didn't have the Allen wrench seated, and it took a little bit of time to get my Allen wrench in there. You can see where they couldn't crack it free, so they've chiseled the side of it. It hasn't affected the sealing area on this particular plug, but you always want to get this thing out first, because if you drain the transmission oil and then you can't get the fill plug, now you got a vehicle that's stuck, can't move. Just a little service tip. So we're just refilling our transmission. I'm using a 75W 90 gear oil, and it's a GL5 spec. In the G50 transmissions, I do use a synthetic oil, just because they use a different synchro system than the 915s, 901s, 930 transaxles. And we're going to fill it until we get just a small amount of oil draining out of the fill plug. That's why we still have our oil drain underneath it as we're filling. Okay, so I have a small stream of transmission oil dribbling out. I don't want to pump it in too much. I'm going to let it sit and drain until it stabilizes. You also want to make sure, obviously, that the car is level. So if you're doing this on jack stands, you need the front of the car jacked as well, because otherwise you're going to end up with a low transmission oil level, as the nose of the transmission will be facing down. So we have all the wheels off the vehicle. Part of a major service is to check the balance as well. One thing I noticed is the hubcaps are very noisy on these wheels. We'll address that when we do the balance. But what we're looking for here is brake pad thickness. And these to me are looking pretty good, but we can see there's some wear differences right here. So this is the right front wheel. The outer pad is wearing a little bit more than the inner pad. So what we'll do with these is we'll actually push them back a little bit, pull them out, clean them, put them back in, lubricate them, make sure none of the pistons are sticking or causing any problems that we need to address here. So a couple of other things we're looking for here is wheel bearing play. Used to be that we would clean and repack wheel bearings at 30,000 miles. Porsche changed that service schedule a long ways back now, back when I was still at the dealer, and went to a straight replace at 60,000. So what I'm doing is just checking for play here, which is good. I've already checked it with the wheel. And then the other things that we're looking for is any boot damage here. These are sealed for life. There is no grease fittings. We're looking for correct alignment on the rack on the inner bushings, and as well as bushing wear there. We're also looking at the steering boot, making sure that it's intact and doesn't have any obvious signs of damage. And we're looking for play in that steering joint. So just shaking the play, which this is nice and tight. We can see we've got minor seepage, or that's actually just the wax that's been painted there. But one of the other things I'd be looking for is signs of oil coming out of the strut, which this car does not have. Okay, so the same on the driver's side. We want to check our pad wear, and we're about pretty even on this side. I'd say pads maybe have 60% life left in. They're a long ways off the wear sensor, so no reason for change. Brake rotors also in good shape, no lips. This is just pad staining. Very normal. First time you go out and hit the brakes, it has rained here, so we did have a little bit of moisture on the car before we put it on the rack. So otherwise still in good shape. Boots in good shape. No wheel bearing play. Strut looks good. Moving on to the rear. Okay, so rear brake pads, plenty of pad life. Good movement on the pads on both sides. Nothing's showing any signs of sticking. Probably 70% life left on the rear. Okay, same on the right rear. Pads, 70% life left. Brake rotor looks to be in good shape. This gives us a chance here looking in at axle boots. So I want to grab the axle and see if there's any rotational play. This would indicate wear in the joints. It's nice and tight. Moves freely. Shocks, no signs of leakage. Bushings, still in reasonable shape. It hasn't contacted metal on metal here. And so even on a car with low mileage, just with the age of the vehicle, because it's always sitting on the suspension, bushings can still wear even at low mileage. So we want to keep an eye on that. But so far everything looks good. No signs of oil leaks from the front oil thermostat. Canister hoses look good. Oil tank showing a little bit of weepage around the oil level sensor, but no more than normal considering they use a cork gasket. Hoses still nice and soft, not showing any leakage signs here either. Okay, so this is the oil cooler fill hose. This comes from the oil tank to the oil cooler. One of the things that we noticed when we looked over the car was the crack right here. The other thing is this hose is rock hard as well. So that happens when, as the hose gets old, it should stay nice and flexible. This is a good chance, since we've got all the oil out of the car, go ahead and change this. Good bit of preventative maintenance so this doesn't break while we're out on the road. Okay, engine service on 3.2s, even though we don't have carburetors or CIS system, there's still a lot of maintenance points we want to hit in here. We are doing spark plugs at a 30,000 mile service, so we do need to get air pipes out, AC compressor off, air filter housing out. We're changing our air filter. We're also going to be doing a fuel filter on this car. One of the couple of specific points actually, distributor, even though there's nothing in, we want to make sure we clean and lubricate. There is an advanced mechanism in here which is purely for rotor pointing. We want to inspect the ignition rotor and the underside of the caps. We also want to be visually inspecting the wires for any signs of cracking. This is a protective rubber here, so we're not too concerned about cracking in this, but if we show signs in the actual cables of leakage, that's something we want to address. Also, we'll be getting all of the spark plug connectors off and checking those. This is something that I find is overlooked today. A lot of shops that haven't had factory training don't know to check these on every service point, and it's very important to see if there's any issues going on with the resistors in those spark plug connectors. So we're going to be putting a new air filter in. This one's not super horrible, that's for sure, but it is time to change it. And this is also going to work. We're going to place this right here on our fender cover, and this is going to give our AC compressor some extra padding so we don't damage our paintwork. So this is something for a service item we want to look at on our fuses. We'll look at the front fuse panel as well. You can see these two 25 amp fuses are starting. The actual fuse material is bowing up. So we want to change that. It's not an over voltage, it's just as these get old, the fuses do get some temperature in them and they'll start to distort like this. So at a service time, we want to look at preemptively replacing things like this that can fail. So we will go ahead and clean the terminal block once we're in here, as well as put in 3 new fuses back here. Okay, so we want to take a look in at the cap, a couple of things. Make sure the carbon brush moves freely up and down, isn't showing signs of excessive wear. Cap looks to be in good shape. And with our rotor, we want to grab it. As I said, even though this advanced mechanism in here does not trigger the ignition, we want to make sure it's moving still. We'll go ahead and pull the rotor, take a look at it here, take a look at the wear here, looks to be in reasonable shape. We'll check a resistance check across here. These ones are a different resistance across the face than the early rotors. And then the other thing we want to do is down in here, we're going to have our felt dart. We want to lubricate that with a little bit of engine oil, and that stops the shaft from seizing up. Also want to grab the shaft, make sure there's no excessive movement side to side. So one of the simple little tricks I do is I take the top fitting off first, put my finger over the top as I'm unscrewing it, creates a vacuum so I don't spill fuel all over the car. There's still going to be a certain amount in there. The other thing I want to do is I want to drain this into a clean container, and that's going to give us an insight to what the fuel system looks like. Looks pretty good. No sediment, no big chunks. Looks great. We'll just put it back in the gas tank. Okay, so I blew out the last remaining pieces. The beaker I was using was a little bit on the small side. And I'm blowing backwards through the fuel filter, so blow from the top down out the back side. Still in good shape. No major signs of anything, no huge debris, a little bit of cloudiness to it now, but definitely nothing that would point me to an issue that we need to deal with. So I don't want to leave the fuel system open for any length of time on this vehicle for 2 reasons. One, I don't want any debris to enter, but also, secondly, if I accidentally power up the fuel pump in service and it's open, then I got fuel puking everywhere. So the other thing to remember, these are tapered fuel fittings. They don't need a lot of torque. One of the most common things that I see is over torque on these. So you always want to double wrench it, and these are just a nip shot. Make sure there's no movement. Hose clamp's tight. You got to make sure the hose clamp engages the body in the back to support it, so the fuel lines are not supporting the fuel filter. So I'm just pulling the spark plug connectors, and on a 3.2 they have these nice brass screw connections, so they'll just unscrew. I don't particularly care what cylinder they come from, but we do need to do a resistance check on all of them. Okay, we're up on TDC number 1, top dead center compression. Verified with my ignition distributor. I've got my rotor back on. We can see the number 1 indicator mark buried down in there. And we're going to do a couple of things. We're going to check our valve clearance and rocker shaft torques, as well as the leak down. And we're doing the leak down as a record of where the car is at. It allows us to monitor wear and tear on the engine, as well as give us an insight into internal cylinder condition. So the top valve cover gasket was definitely showing signs of some oil leakage. You notice the whole bottom side of the gasket is wet. Oh my God, whoever did this last.
Oh, the nuts are really tight, but the...
Well, that thing is still loose. There we go. That feels nice. Okay. Leak down looks like about 3 to 4%.
Cylinder 1.
Cylinder 1. Oh my God, it's not holding crankshaft in. There we go. So the last person that did this job, probably at the 15,000 mile service, really over tightened the rocker nuts. These don't have to be that tight. Usually what will happen is if you over tighten them, you'll actually pull the threads up on the adjusters and make it almost impossible to adjust. So just one thing to keep in mind when you're doing this, don't over tighten. Looks like about 8% on this one. %. This one was so tight I couldn't even feel any movement before I started. I couldn't even get close to getting the gauge in. Nice. I'd say 8%. Nice, it'll work. Not better. Say 4% again. Yeah, it's not budging. You should be able to grab them and rock them and have a pretty good idea of how close they're going to be. And yeah, I can't get the feeler gauge in it. I feel that the threads are a little shitty. There we go. And now I can move the rocker. Cylinder 5, we're at 4% as well. Okay, so that wraps up our valve adjustment and leak down. So we haven't done leak downs on this car before. We've now establishes a baseline, and depending on how many miles it actually gets, as a lot of these cars don't get the kind of mileage they used to, we can maintain and kind of keep an idea on how things are going. So right now, between 4 and 8%, depending which cylinder you're in, which is all great numbers, what I would expect to see from this kind of mileage. We're going to move ahead and retension our rocker shafts. Even though there's no signs of leakage coming out of any of those shafts, it's still just part of the service. So I can't fit a torque wrench in here, so I'm just checking that they are tight. I'm using a quarter drive ratchet with a 5mm Allen wrench socket that's being custom ground to fit in there. And I just got to work it out and move on to the next one. So the plug gap we're looking for is right around 28 thousandths, so I'm just going to check these. Perfect. So I've just installed the top covers and torqued all of the bolts down correctly. Have spark plugs also back in, distributor cap back on, and just moving forward I'll get my ignition cables screwed back in on my spark plug connectors and just keep putting it back together on the top end. Then I'll scoot down underneath. We're going to have to pull the airbox out of this car. It's never had a mixture adjustment. The plug is still installed in the airflow meter, so we'll go ahead and pull that out before we put anything back together over this side, just in case we need to adjust the fuel mixtures. So this ground point here on the intake manifold is a well-known problem area for these cars. If you get any corrosion in here, it can make it do weird things, from injectors locking open and staying open, to weird running conditions, to even no start. So we always want to pull this off and just clean it really well while it's in for service, kind of get in front of any issues. So we can already see there's a little bit of corrosion starting to form. And it's just because of where it's located on the manifold. It's in a wet area. When it rains, water comes straight down onto this area and can corrode these terminals. Okay, so just a quick cleanup and we're ready to go back together. Okay, nice and tight and clean. So I've gone to just pull our airflow meter out, and we can see here that this bolt has already loosened up by itself. Chance to feel the throttle plate, not too oily. So on the airflow meter, this is what's metering the air. The mixture adjustment is under this plug, and this plug is put in so it can't be adjusted. Now, that's true and not true. There is an actual spec, and it's right here on the tune-up information. It's 0.8% CO, plus or minus 0.2. So even though the O2 sensor is controlling the air-fuel mixture, we need to set the baseline. So this is underneath here is going to be a 3mm Allen head screw, and I'm just going to pull this plug out and then put it back in. Same for the idle speed setting. This plastic plug right here controls the idle air bypass. This is the idle control motor. So technically this will control the speed, but once again, there is a base setting for idle speed, 880 plus or minus 40 RPM. And the way that we check for the base idle speed is we're actually going to bridge out the diagnostics plug. That's going to put our idle motor into a neutral position, and we want to make sure the engine's idling in the correct range. Once we unplug the diagnostics plug, then the idle control motor will take over. So if we look down in there, we can see there's a 3mm bypass screw with the plug out. And what this does is it just changes the amount of air that bypasses the barn door. As airflow comes into the airbox, it opens up this door, moves a rheostat around here, changes the electrical signal going to the computer so it knows how much air is coming into the engine. So to increase the mixture strength, we would typically screw this in, which closes off the air bypass and makes the barn door open up more. To lean it out, we would screw it counterclockwise, means more air bypasses the barn door, doesn't open as much, and less fuel is injected. Okay, so resistance on spark plug connector should be 3,000 ohms plus or minus 10%. So that's 2,700 to 3,300. Then the most important thing is to tap the connector as you're checking. The reason being is inside here there's a small resistor pellet. It's about 1 inch long right here. There's a brass rod and there's a spring. These springs have a tendency to break and they'll create an intermittent misfire. So that one's fine. I'm also using a long extension so I can get all the way down. Okay, so all of these came up fine. We can just reinstall them when we put things back together. So ignition rotors on the 3.2 liters, which is 84 and up, 84 to 89 should be 1,000 ohm resistance, plus or minus 10%. We're hair over, not enough for me to warrant changing. If I had a lot of damage right here, I would. It may also be a little cleaning issue if I can get a better number. It's pretty consistent at 1.158. If it was 1.2, I would change it. But right now, it's totally fine. So I just cleaned the rotor up. I didn't take much. A little bit of sharp emery cloth. Just cleaned the surface. Still in good shape. No issues. The other thing I want to look for here is signs of overheating or cracking. And then very importantly, you want to turn the rotor over. Make sure there's no black spots down in here. Sometimes, not so much with the DME cars, more with the CDI cars, they can burn through from here to the rotor post. The DME cars are significantly reduced in energy versus a CDI car, but still something you want to look at. So we're just pulling all the plugs now, starting on number 6, doesn't matter where, but this one was actually loose. So we'll see what the seat looks like once we get it out. Okay, plug itself doesn't look too bad. The thread was all dirty just because the plug wasn't seated properly. But otherwise doesn't look bad. Average amount of wear. And we're going to replace them anyway. These plugs are still readily available and are relatively inexpensive. So I just put in on cylinder 3, and this one is really finger tight. I mean, I didn't have to do anything. You can hear the thread squeaking. Oh yeah, the plug shows it too. Lean as, just white. So yeah, this has been sucking some air. Okay, so I finished with all the valve covers, uppers and lowers on. I have my new S-hose on from the oil tank to the oil cooler. Changed the oil filter, just moved the AC compressor to sit here. We've actually got to change an AC line as well before I put all the air filter back together. But I'm just going to do my initial fill with the engine. With these I usually start with around 10 liters. Cranking same thing going on our front fuse block. Not every fuse needs to be changed. Most of the 25 amperes, so we got 1, 2, 3, 4, 5, 6 need to be changed. And these 3 16 amp fuses are due to be changed as well. The lower amperage ones look like they're in better shape, but I can probably go ahead and leave those. This is a sway bar link that took a hit going over something. Also was the last thing hit on the way out after taking out our AC hose. So we're moving on to the brake fluid flush portion of the major service. This is something that gets neglected a lot. I can see cars that have had regular brake fluid changes, and this should be done every 2 years. What you generally see is brake calipers that seize up and pistons that get stuck into the caliper bores, and it necessitates a much more expensive repair, so it's cheap to change brake fluid. I've already sucked all of the fluid out of the container, and for right now I've got the little baffle that normally sits in. This sits inside. I've cleaned it. There was a bunch of black debris in the bottom, which is normal. This normally sits here for the piston, for the brake warning light to sit in. And what this does is it dampens the brake fluid. So like if you're cornering hard or braking hard or accelerating hard, it keeps the level constant and doesn't turn the brake fluid light on the dash to cause other problems. So I've just taken it out for the bleed process. We've cleaned everything out of here, so now we're just going to flush the lines. So I'm starting at the caliper furthest away from the brake master cylinder, and just going to open the bleed screws, and I'm going to have the brake pedal pumped just to flush that fluid through. Okay, pump it up. Solid?
Yep.
Hold it down. Now we can release it. Okay, so this is the caliper where we noticed some different pad wear on the outer pad versus the inner pad. And when we went to pump brake fluid through it, I opened the valve up, but we really didn't get the same flow. So this feels like there is maybe a minor blockage. I wouldn't say it's completely blocked because I can still turn the brake rotor, so the pad's not stuck against it. But I just released the anti-rattle portion. And we're going to see if we can push it back without spraying brake fluid everywhere. It really doesn't want to move. All right, so I was able to pull the pad out and then take my small pry bar and pry each piston back into the bore, and they were pretty well stuck. And I think what the problem was is there was a bunch of crud built up on the inside, and it was not allowing the pistons. They should suck back in slightly, so when you put your foot on the brake, pad moves away, and then the seal actually pulls the piston back a small amount. And I think what was happening is these pistons were moving out, but they weren't moving back. That was causing this pad to wear. So we're going to try and bleed it again. I had the bleeder valve open while I did this and was able to push all of that fluid out. So hopefully if there was any debris in there, we've already pushed it out, and we'll try and bleed it again. So this is how much brake fluid we flushed out of the system, not including what I sucked out of the reservoir. You can see it's a little bit darker. The debris is just from the underbody. My hands are covered in it as well. That's what's on the brake calipers. But it's a good idea to get this down every 2 years. Okay, so my brake fluid level is right on the max. So I'm going to go ahead and put my baffle back in. It's going to take a minute for this to fill up. There's a little tiny hole on the bottom that bleeds through. Let it bleed through, and we're just making sure that my fluid level, it'll settle down right on that max mark once the fluid makes its way into that baffle. And that's it for the brake fluid. Putting the AC system under a vacuum to recharge it after replacing the hose that was damaged. So I'm just wrapping up our major service on this car, and I noticed that our door tread was loose at the back. And I have pulled it off. I've already cleaned the glue. I've got a little bit left to get off here. But the glue that somebody's tried to re-glue it once before, and it's just failed. So I'm going to clean all of this up, get rid of all the old stuff, and re-glue it back to where it needs to be. So I've just heated the car up, and I've added about another 2 liters of oil. And right now we are right on the full mark. Okay, so I have the O2 sensor disconnected right now, and we're looking for around 0.8 to 1% CO. Right now it's running at 3.35% CO, which is a little bit high because we want our O2 sensor to be able to control it. If our starting point is too high or too low, then the O2 sensor will just be stuck at one end of the band. So we're going to adjust that down. So right now we're at about 1.5%, which is where I'm going to leave it for this car. This car lives at a much lower altitude than ours. Our current altitude is about 7,300 feet. So this car usually lives at 1,500. So it's going to lean it out a little bit as it heads down, back down to its normal altitudes. So I'm going to go ahead and plug the O2 sensor back in, and we'll see what kind of an effect the O2 has on the fuel mixture.
Lower percentage, or
that's what the O2 sensor does. That's its job. So we can see the O2 sensor is leaning the car out considerably. Now lambda is 1.03, so it's actually a little bit on the leaner side. Hydrocarbons are at 20 hydrocarbon, CO2 13.95, 14, which is really great. O2 around 0.3, so it's burning that entire hand charge. And the O2 can now control that fuel mixture a lot more efficiently without having to ramp it from 3.5%, which is where we started, all the way down to 0.6 of a percent. Kind of surprising considering we have to drill the plug, so I'm assuming we're the first ones in. Normally you find these cars want a little bit more fuel, they're usually a little bit on the lean side, but this one is very rich. So the last thing we want to do as part of our service is we want to check the base idle settings. So I'm going to use my jump wire. There's a diagnostics plug in by the fuse board. We're going to bridge terminals B and C. And what that's going to do is put our idle air control motor in a neutral state. So not holding idle up, not holding it down. We're looking for around 840 to 880. And if we have to adjust it, we'll just break this little plastic cap off and we can adjust the idle speed. Using the vehicle tack to screw that down a little bit. Around that 900 mark on the tack, so I'm going to pull my wire out, and our idle control motor will take over again. And I can take my plastic cap, push it back on, and that's it for our tune-up settings.